All right, so this is such a cool question because what we're trying to do is we're trying to find the original function f of x when we have the derivative and we have just one function evaluation, f of 1 is equal to 4. So to answer or to find this original function of f, we have to use our fundamental theorem of calculus, which says that integration and differentiation are opposites of each other. So just like multiplication and division, they cancel each other out, the same thing is going to happen with integration and derivatives. They're going to cancel each other out. And one way of thinking about this is that when you integrate one time, you are going to lose one prime. So what will happen here is when I integrate the derivative, the integral sign, which again is associated with this dx always forever, the integral sign is going to go away, the f prime is going to go away, and because the integral and the derivative are opposites of each other, this will leave us with little f of x. Now, we can actually find the definition of little f of x because we have the derivative. Now, we know what's coming up. We're trying to integrate this derivative. So in order to integrate, I would first have to bring up the x to the 4 into the numerator as x to the negative 4. So I'll go ahead and write that, the 7x to the negative 4 dx. All right, so to integrate, the 7 is a constant coefficient, so it is just going to tag along for the ride. The negative 4, I add 1 to the exponent and then divide by the new exponent. Then, because there are no bounds on this, I need to add a plus c. All right, so our first step here is that we integrate. So we integrated, and what that did for us is that we got from our derivative, by integrating the derivative, we got our little f of x. But our little f of x function is still in terms of a plus c. So our second step is that we need to go and find what that plus c value actually is. And to do that, we use the only piece of information we have yet to use in the problem, and that is this f of 1 is equal to 4. So we've already used our derivative information. Now we're going to use our f of 1 is equal to 4. All right, so how do we use that little piece of information? What we do is f of 1 equal to 4 means that at x is equal to 1, we are going to have a y value of 4. So we're going to plug in x equals to 1 into the current function that we have. So if I go below here, plugging in 1, I'm going to have 7 times 1 to the negative 3 over negative 3 plus c. Now, it might be helpful to kind of rewrite all these this negative exponent we have. So really we have 7 over negative 3, 1 to the positive 3 plus c. And that is going to be equal to just negative 7/3 plus c. Now, in order to make any progress with this question, we can't just plug in 1. We have to use what the other piece of this information is, and that is that f of 1 is equal to 4. So in for this f of 1, I'm no longer going to keep referring to it as f of 1, f of 1. I'm now going to say that f of 1 equals 4. So I replace the f of 1 with 4, and now I just have one equation and one unknown, and I can solve. So here I have my 4 equals negative 7/3 plus c. So to solve for c, I will add 7/3 to both sides, add 7/3. Now, you should be able to get a fraction here without a calculator of any sort. So here I have 4 over 1, so I'll multiply 4 by 3 over 3. So that gives us 12 plus 7, so 19 over 3 is equal to our c value. Now, just saying that c is equal to 19 over 3 is not the final answer because we need a function. So in order to get our function, we're going to use the fact that c is equal to 19 over 3, coupled with what we found from step 1 of integrating, to say that our final answer is going to look like f of x equals negative 7 over 3. And again, to make sure that the answer choice is correct, we could either move the negative exponent down or keep it as a positive exponent or a negative exponent, and then plus our c value, which is 19 over 3. And that is our little f of x function. And that's a very cool thing that we were able to do because we were able to start with just the derivative, the rate of change, and one function evaluation and work backwards to the original function. And we did that again by integrating finding our c using f of 1 is equal to 4, and then our third step was just putting it together and saying what our f of x function is with that found c value plugged in.